Hello and welcome YouTube, Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Alright, step on inside and we are going to be doing part 2 of that sequence and series review that I also promised, and here it comes. I will be using my calculator here, so if I need to flash something up, I'll go ahead and do that. I'm assuming you've seen part 1 as far as things that I've explained. We'll see what different kinds of questions are involved here compared to the other ones. Honestly, haven't seen this one in a long time myself to even know what they are. But let's go ahead and get started and check it out. All right. Now this covers a plethora of things. You're going to have to know some of your formulas or kind of hear it out as I say them. Again, I'm assuming you've seen the other ones. You've had some notes. You've done some things before. This is drill and kill, making sure that we know how to do these, what kinds of questions being asked, how to attack it. Number 1, using the arithmetic sequence 3, 7, 11, 15, let's find a sub 22. Now a sub something is with regard to the actual sequence itself. We're finding the value of the 22nd term. So I will write out the formula as far as this goes, so you know what formula I need to write right here. I'm trying to find, I'm going to write the explicit rule for the arithmetic sequence basically. I don't want to keep adding 4, which is my common difference here. I don't want to keep adding 4 until I find the 22nd term, but you are adding 4 in that regard. So D is 4. That's your common difference. N is something we're going to substitute in just a moment here, and the value of the first term is 3. So to find the value of any term n, we will start from 3, and we will add 4, and minus 1 times. To find the value of the 22nd term, starting from the first term 3, we will add 4, 21 more times, because of course we start in the first term. 4 times 21 is 84, and 84 plus 3 is 87. The value of the 22nd term is 87. Let's find S sub 16. Let's find the sum of the first 16 terms of this arithmetic sequence. As the sequence goes on forever, they're saying find the sum of the first 16 terms. In order to find the sum of the first 16 terms, we'll be using this. I guess I'll write the formula when it shows up if it's the first time. I'm going to be using this formula right here. This is for arithmetic sequences, where to find the sum of the first 16 terms, we state, in this case, there are 16 terms. So we're going to divide 16 by 2. That kind of pairs off your terms, if you will. And it can pair off the first and last term, second to last term. The first term is 3, and the last term is the 16th term. We have to find its value here still. So we need a sub 16, and it helps that we have the formula here already for it. 3 plus 4 times 16 minus 1, or 4 times 15, is 63. 60 plus 3. So we do 3 plus 63 there. In calculating that, 16 over 2 is 8. And that's 8 times 66. I don't want to make a mistake, but it's 480 plus 48. So 528, I do believe. 528. Let's be sure. 66. I shouldn't need this. 528. Okay. The sum of the first 16 terms is 528. All right, what term number is 219? So they're asking the value of some term is 219. The a sub n is 219. I want to know the n that represents that. How many times do you have to add 4? When you keep adding 4 over and over and you land on 219, which position are we in? So this time, a sub n is 219. And given our formula right here, we're going to solve for n. So if a sub n, if 219 equals 3 plus 4 times n minus 1, we're going to go and solve for n here. Some people distribute here. I've been avoiding it because I know that the answer needs to be an integer, so I can divide by 4 ultimately in this quantity state. I'm going to subtract 3 from both sides first to get 216 equals 4 times n minus 1. This is where I like to divide by 4 instead, just personally. So we get 54 equals n minus 1. Add 1 to both sides, we get n equals 55. So the 55th term has a value of 219. If you were asked what term as a sum, how many terms did it take to get a sum of 219? I'm not saying 219 is a sum, but you would substitute that into here, and then you'd solve for n in that case, and you'd have to know, I guess, what the last term's value is. I did a problem like that actually in the last video, where the last value is kind of like you got to use it in terms of a sub 1 to make that happen. So it was kind of interesting. All right, number 2, expand, then find the sum. Now this time, listen, this is very arithmetic series. Heck, it's an arithmetic series. It's very arithmetic series-like in that it is an arithmetic series. But we're not going to use this formula here. Literally, it's actually asking you to expand. Actually, let's get all 4 terms out explicitly by substituting 1 in for n, 2 in for n, 3 in for n, and 4 in for n. It's only 4 terms. So the first term will be substituting 1 in for n. And what we're going to do is we're going to take this and we're going to add this sigma notation. That's a summation. You're going to be adding everything you substitute in for n into get it. You're going to take the first term plus the second term, etc. The second term, you don't need the brackets. This is just differentiating the terms. The second term plus the third term minus 8 plus the fourth term. And yes, you'd have to know the first term. See, listen, honestly, this might be less work than doing the sum thing, because you would need the first term and the fourth term anyway. And then you got to plug things in, so it's not much worse. -3 times... Now, also, it didn't really ask how you do this. If you know what the first term is, and if you know that -3 is your common difference, I guess you could do that. They just asked you to expand it. So the first term is -3 minus 8 is -11, plus -6 minus 8 is -14, plus -9 minus 8 is -17. You can see that common difference of 3, -3 working, plus, I guess, -20. -12 minus 8 is -20 right there. So now we compute those, -25, -42, -62. And it should get further negative, right? They start negative, they continue further negative. All right, number 3, write the first 4 terms given the following rule. Now, this is the first recursive rule thing that we've seen for a while, and this is for a geometric sequence. I know this because this states to find the value of some term, take the value of the term before it, and multiply by 3. So I'm going to give you kind of a really slow version of it to start with, just so you know how the formula truly works. And then we can go the fast way after that, of course. So right here, a sub 1 is 5. Look, the first term of the sequence is 5. Now, if I wanted to find the value of the second term, I would take a sub 2 minus 1, a sub 1, and multiply by 3. Well, we know that a sub 1 is 5, so we do 5 times 3. So a sub 2 is 15, and that's where we get that 15. A sub 3 takes a sub 3 minus 1, or a sub 2, and multiplies by 3. Well, a sub 2 is 15, and 15 times 3 gives us 45. You see that recursion? You see that looping through and repeating the process over and over, but for the new value, and you can't find the next one until you use this new one, at least based on the rule that we're working off of. See how that makes sense? Now, we do this a much more efficient and faster way, but this is how this rule works. And furthermore, this is why you need the value of some term. We like to start with the value of the first term, so we can really write our list out. 45 times 3, which is 135. A sub 4 is 135. So, comma, 135. But what I would actually do is I would say, what's 5 times 3? What's 15 times 3? What's 45 times 3? But if you don't know how the rule does that really fast, you could plug those things in, and that's what happens. It's a substitution of the previous value, multiply it by 3, and, you work it out. But that's the first 4 terms given the rule. It's a geometric sequence, as that has a common ratio of 3. All right, number 4, rewrite in summation notation 8, 11, 14, 17. I don't like the problem because it should probably say plus, I guess. Sort of. Because, it should, for a series, it should say plus, but summation notation means sigma notation. We need that sigma thing going on here. What we need to determine is, okay, so just imagine it did say plus, because I feel like it's supposed to have a plus for it to actually work that way. We have to recognize how many terms are there total, going from first to last. We're going from first term to the fourth term. And then we have to come up with the explicit rule. The whole thing about this thing working the way that it is you plug in 1 for n to get 8, 2 for n to get 11, 3 for n, 4 for n. So we basically got to come up with the explicit rule. We're going to write that inside the sequence thing, and it'll work out. So the value of the first term is 8. The common difference is 3. You can tell the plus 3 is happening there. So as far as this rule goes, just to start, this isn't summation notation. This is just the explicit formula. This is going to be starting from the first term, we add 3 n minus 1 times. So we can use this rule. Now, if you ever want to simplify it, we can distribute the 3 and combine 8 with -3 and get, like, say, 3n plus 5, something like that, or 5 plus 3n. So you can either use this, or this interchangeably. Doesn't really matter. They're both explicit rules. What we're going to do, I'm not boxing it for the answer, but what we're going to do is write this in summation notation, sigma notation. Draw sigma. This goes from the first term to the fourth term of this sequence. Either you can write 8 plus 3 times n minus 1, like that, or you could have written 3n plus 5. I've been doing a little more of this one. This is the formula I've been following. But because we see some answers like that, negative 3n minus 8, 3n plus 5, I wanted to represent it in a way that also can make sense there. Now notice I do put parentheses around the entire grouping to say this is the thing I'm doing the summation of. And that'll give you 8 plus 11 plus 14 plus 17. All right, find a sub 52 if a sub n equals 2n minus 8. All right, substituting 52 for n. I'm not going to spend a lot more time lingering on that. So a sub 52 equals 2 times 52 minus 8. Which is 104 minus 8, which is 96. That's it. The value of the 52nd term is 96. Find the 122nd term if a sub 1 equals 20 and d equals 3. Now, this is an arithmetic sequence. There's a lot of arithmetic so far. This is an arithmetic sequence because you are given a common difference. Find the 122nd term means it would be nice if we wrote the explicit formula for the arithmetic sequence. A sub n equals 20 plus 3 times n minus 1. The 122nd term is a sub 122. So far, this seems easier than the previous worksheet. 20 plus 363, which is 383. Yes, that is the value of the 122nd term there. All right. In the previous problem, what term has a value of 191? Well, this is we're not doing a sub 191. We are substituting 191 for a sub n, and we're trying to figure out what n gives us that. So this is like equals a sub n. So 191 equals 20 plus 3 times n minus 1. And as you know me, I'll go ahead and subtract 20 here, get 171. And then I'm going to divide both sides by 3. Fortunately, I don't know the answer. 57 times, yeah. So 57 equals n minus 1. Add 1 to both sides. N equals 58. That is the 58th term that has a value of 191. So sometimes you substitute for n. More times than not, you seem to figure out the value for that specific term. And sometimes you're given the value and you have to find the term assigned and associated with it. All right, number 8, find the recursive rule for 5, 11, 17, 23. They don't tell you what kind of sequence it is, but like has been the case for a lot, this is a lot of arithmetic sequence. Like the case for a lot of the arithmetic sequence things before, yeah, I see a common difference of plus 6, so it's going to be an arithmetic sequence here. But hey, we haven't done an arithmetic sequence recursive rule, so let's go ahead and do that. First, we state the value of some term is going to be taking the value of the previous term and adding 6 to it. Adding your common difference. That's how we work that thing out. And we got to state the first term along the way. That's important to getting you started, just like I was able to write the first 4 terms of sequence because they told me what the first term was. If I didn't know, then I couldn't start it. You can't just assume you start from 0 or 1 or something like that. You start from where they tell you. And we tell them you start from term 5. Okay, there's the recursive rule. Find the sum if a sub 1 equals 29, a sub n equals negative 112, and d equals negative 3. So when they're saying find the sum here, they're saying that a first term in some series, right? This is a series. They say find the sum. A first term in some series of numbers is 29. The last term in the series is negative 112. All your terms are separated by negative 3. As in, this would be, the first term would be 29. They're saying do 29 plus, what's 29 minus 3? 26 plus 23 plus 20 plus, and this keeps going. And this gets to negative 106 plus negative 109 plus negative 112. It keeps going over and over all the way through. So you keep subtracting 3, and I guess that's what's going on there, right? It's a lot of terms. How many terms? We don't know yet. We haven't gotten that answer. We got to figure out how many terms there are. And now for us to do that, I think it's important that before, see, we have to know how many terms there are for our formula. We're going to be using this one. And we need to know the following. The value of the first term, we got that. The value of the last term, we got that. The number of terms, we don't got that. And I ain't going to count it. I ain't going to keep going forever and ever. I'm going to use a formula that we have. The explicit rule formula also uses the first term, last term, and number of terms, and common difference. Again, if we use this, a sub n equals a sub 1 plus d times n minus 1, we have the last term in the sequence, the nth term, based on the number of terms there are. We have the first term. We have the common difference, plus d is minus 3, and we're going to solve. We're going to solve for number of terms. That's not the final answer, but that helps us get to the final answer. And I know there were problems like this in the first review. I don't know if it was written this way, but there were problems like this in the first review. I'm trying to move this. There we go. All right, subtracting 29 from both sides. Remember, not 29 minus 3, but minus 29 from both sides will give you negative 141 equals negative 3 times n minus 1. Divide by negative 3, that is 47. Yeah, 47 equals n minus 1. Add 1 to both sides, you get n is 48. So we're going to use that. Make sure you don't get a negative answer. We can't get a negative number of terms. And again, you can't get a decimal answer. So if something like that happens, something went wrong. Okay, 48 terms total. That's how many terms from the first to last term. So it's a series. So the sum, I'm trying to move this. There we go. The sum of the first 48 terms is 48 over 2 times the value of the first term plus the value of the 48th term. Okay? So that's going to be 24 times, not much room here. I'm bad with math now. 103, 83, negative 83. I'm going to let the calculator do that for me. 24 times, make sure 29 minus 112 is negative 83. Yes, it is. Times 24, negative 1,992. And it makes sense that the answer is negative because even though you start positive, you're adding 29 plus 26 plus all that. You know, eventually they start leaning toward negative. You get all the way to negative 112. You're adding a bunch of negatives leading up to there, including, like I said, negative 106, negative 109. It makes sense to get that kind of answer. All right. Number 10, evaluate. From the first term to the 16th term here. They don't ask you to expand this time, so I am going to use the, this is all arithmetic. I'm going to use the arithmetic series formula again with this. I got to check and see if there are more geometrics here. I'm not sure anymore. I'm almost not convinced. Sorry if we don't get a lot of geometric here. So in order for this to work, we're going to be using this, this formula here, n over 2 times a sub 1 plus a sub n representing the last term in our sequence here. So we have the first term and we need to find the first term and the last term, the 16th term. So the first term is 3 minus 4 times 1, which is negative 1. The 16th term is 3 minus 4 times 16. Negative 64 so negative 61. And the number of terms is 16 from the first term to the 16th term. It's not always just this number. You have to make sure that this is a 1 if that's the case. So the number of terms is 16. Okay. Should I mention that? No, it's okay. All right, so what we're going to do now is we're going to be using this formula here. So to find the sum of those 16 terms in the sequence, we're going to take 16, n, divided by 2, and multiply it by negative 1 minus 61. Negative 1 plus negative 61. So that's 8 times negative 62. I have a song that just keeps playing in my head even while I'm talking. I want to make sure I don't just sing it out loud in a second. Which is negative 496, I think. Negative 496. Got to double check. 8 times 62. Yeah. All right, negative 496 is your sum there. All right, number 11. Solve for x. Okay, that's interesting. K is this thing. All right, so there's no n here involved. Now it's from k equals 1 to k equals 5. I feel like there was more in this problem because you can't solve for x unless you know the sum. Let me see if I'm missing. Let me see if I'm missing something in this problem. Give me one moment. Otherwise, this doesn't seem to make any sense. Okay, I am missing information. It should say equals 620. Yeah, otherwise you're saying the sum. There's nothing to solve for if there's no comparison to something, right? You're just expanding out a sum. It won't work otherwise. All right, so we're using k instead of n, but that's okay. You can use q. You can use whatever as long as the variable's here. So you can use one of two ways. Wonder which way I should prefer. Let me see if both just kind of work as far as what it is that we're going to do here. You can either, because it's only 5 terms, if you're comfortable expanding this out, it doesn't seem like the worst thing. So if you expanded this thing out, plug in 1 for k, 2 for k, etc., you'd have 1x minus 2 plus, and then plug in k is 2, 2x minus 2 plus 3x minus 2 plus 4x minus 2 plus 5x minus 2. And all of that equals 620. Right? That's the idea behind kind of what's happening there. This sum equals 620. We're going to find out what value of x makes this true. So all the negative 2's added together gives you negative 10. 1x plus 2x. You want to do an arithmetic series for 1 plus 2 plus 3 plus 4 plus 5? That's 15. So 15x minus 10 equals 620. We're going to add 10 to both sides and divide both sides by 15. So 15x equals 630 and divide both sides by 15. You get x equals 42, I think. Answer to life, right? Is that how you say it? Hitchhiker's Guide. I think it's 42. 630 divided by 15. 42. Okay, so that's the answer. That's solving for x. Now, how could have I done it differently? Especially what if this wasn't 5? What if it was 50? What I imagine we could do is use the series formula like this. You know how many terms there are, and we would just plug in the first and last term into this. So instead we'd say, all right, here's your a sub 1. Here's your a sub 5, right? There are 5 terms. So we could have said s sub 5, which by the way is 620. Let me do that right now. 620 equals, and we would do 5 over 2 times a sub 1 plus a sub 5. Like that. So 620 equals, I'll keep it as 5 over 2, times x plus 5x is 6x. Negative 2 minus 2 is negative 4. I don't know. If you want to distribute, do whatever. I might even factor a 2 out of there. 620 equals, let's distribute. That's 30x minus 20. This is still all over 2, by the way. Mind if I multiply both? Oh, let's just divide those by 2. So 620 equals 15x minus 10. You see where we're getting to a stage that we got here before? Right there. It looks like it took a second longer, but if you had more terms, it's probably worth doing that there. That's still using the series formula in that kind of way. But anyway, unless it equaled 620, you can't really do anything with the problem to solve for x, and there it is. X equals 42. X equals 42. Okay, there is that one. I'm going to flip the page. Let me check. I don't have... Okay, here's some geometric. Here's some geometric, but they're infinite series. And there's another geometric. Not much geometric. I kind of apologize on that. I didn't recognize that this has so few... Oh, here's... Oh, means. Okay. I didn't see this question. Insert 5. Let me pause to get some water here. Okay, try to hold my breath. Here we go. All right, insert 5 arithmetic means between 22 and 138. So between 22 and 138 here, there are 5 numbers. We're going to add d one more time than there are terms, right? It's plus d this many times. I should really show you a different form of how you're probably supposed to solve this without, because what if it's 30 arithmetic means? I'm not going to have you write all that. There are other ways that we could kind of come about this number, and I think it's probably worth me showing you in one of these cases here. I mean, part of it is you're trying to find the common difference. If it's 5 arithmetic means, the only thing is you just got to know how many terms are in between one term and the other term. I don't know. I think it's fine either way. Anyway, so our equation here says 22 plus 6d equals 138. Like that. Subtract 22 from both sides. You get 6d equals 100. I'm so bad at this. 116. I hope. And then that becomes... Does that work? Yeah, 6, right? And then divide by 6. Oh, that's right. The common difference doesn't have to be an integer. I was like, that doesn't work. So 116 over 6, which if you reduce that, that becomes 58 over 3. I don't want to write the decimal for that because reasons, because that would only approximate it. We have to insert the arithmetic means there. Let's make sure all the math is right. I just don't trust my math right here. 116 divided by 6. Okay, so now we're going to come up with these numbers here. Now I'm going to leave them as fractions. So I got to do 22 plus 58 over 3. I'm going to write it as a fraction. That number, etc. So 22 is also 66 over 3. 66 over 3 plus 58 over 3 is 124 over 3. Oh, which is a whole number. Wait. No, it's not. No, it's not. Is 124 over 3. So this is 124 over 3. 24 over 3 is a whole number, but not 124 over 3. Let's just keep it over 3. 124 over 3 plus 58 over 3. Yeah, duh. Every third is going to be, every 3/3 is going to be another whole number. And there's nothing I have to reduce here either. If it's over 3, I can't check out the 3 anymore unless I can actually divide it by 3. So that's going to be... I blanked. 182 over 3. And then we do it again. 182 over 3 plus 58 over 3. And this one should be a whole number. And I'm going to tell you a faster way we can kind of get this number after. This is 240 over 3. There we go. Which is... Now I want to leave 240 over 3 for this one. But 240 over 3 is 80. So 80. Now how else could I have gotten this number faster? I mean, you still have to get these other two. But... This is 22 plus 58. Just plus 58. If the other ones are 58 thirds and you do it 3 times, then this is going to be plus 58 right there. That means 80 plus 58 should give you 138, and it does. Now, I still got to get the other... Ooh, I need more room for this. 240 over 3 plus 58 over 3 is 298 over 3. 298 over 3 plus 58 over 3 is 356 over 3. And to make sure I didn't mess anything up, 356 over 3 plus 58 is 412 over 3. And 412 over 3, I'm really bad at my math, 130 times 8. No, 422 over 3. No. Wait, hold on. What did I say? Hold on. I can't do my math, maybe. What are we adding? 58 over 3? Yeah, that would be 414 over 3. What is 414 over 3? 390, 130. Yeah, that's 138. Okay, 414 over 3. I apologize. I said 412. 414 over 3 right there. All right, that'll be it. So those are the arithmetic means there. Isn't it fun watching this live from a teacher struggling with this stuff? It humanizes. Some people say it's a lack of credibility. I say it really humanizes the elements and says, we're human, we make mistakes, we have this conversation stuff as well. We should probably use a calculator. It's really what it says. We should probably use a calculator. All right, number 13 right there. Insert 3 geometric means between 9 and 16 ninths. Forget you. 3 geometric means 1, 2, 3, and then 16 ninths. So we're multiplying by some common ratio here. Times R. Times R. It's the first time we've seen geometric something in a while. Times R and times R. We're multiplying 4 times from there. So 9 times R to the 4th is 16 ninths. If I divide both sides by 9, that's the same thing as multiplying by 1/9. So that becomes R to the 4th equals 16 over 81. Which can't reduce, and I don't really want to. What I do want to do is take the 4th root of both sides, though. The 4th root and the 4th root. 4th root of 16 is 2, and the 4th root of 81 is 3. So the common ratio is 2/3. So we're going to multiply 9 by 2/3. No biggie. It's 9 over 1. 9 times 2 is 18. 18, well, 2/3 of 9. And 18/3 is 6. Now we multiply 6 by 2/3. 6 times 2 is 12. Divided by 3 is 4. 4 times 2/3, that gives you 8/3, and that's, I'm going to keep that as a fraction like that. And 8/3 times 2/3, 8 times 2 is 16, 3 times 3 is 9. Those are our things. Oh, I messed up. Sort of. 4th root of something here. I'm so sorry. It's plus or minus 2/3. Plus or minus 2/3. You can have a negative 2/3 as well in that thing when we multiply this. So if we multiply negative 2/3 4 times, you'd get potentially either positive or negative 6. But let's say multiplied by negative 2/3. You get a negative 6 here, a positive 4 here, a negative 8/3 here, and then a positive 16 ninths here. So this could be your sequence. We don't know. whether the sequence is 9, 6, 4, 8/3, and 69ths, or 9, -6, 4, -8/3, and 69ths, where it changes signs each time. The 9 and 69ths are definitely positive because that's what they gave us. The 4 definitely has to be positive because even if they were negatives before that, you multiply by another negative to make it positive, alternating signs. And these could be positive or negative. If one is positive, the other has to be. If one is negative, the other has to be, depending on the common ratio that you are working off of. It is one or the other. They don't know one way or the other. That's all we have to work off of. So those are the answers. All right, cool. Okay, number 14. What is the first term of a sequence if a sub 5 equals 28 and a sub 20 equals 88? Okay, this is one of those good examples of this could be used as a geometric mean problem. You could find the common difference that way. But you can kind of, you can work things out in a different way as well to assist you. Let's see, how do I say it? You can work things out in a different, like, this is very slope-intercept form kind of stuff. This is very slope-intercept form kind of stuff, as in, this is like, if x is 5, y is 28, and if x is 20, y is 88, and we want to find out what what y is when x is 1 kind of thing. So if you found the slope, you can work it out. There are other things that we can write and work this out in, and I think it's worth talking about it in this case here, because we're not just using recursion to fill in blanks and such. So what we're doing is this, and I'm going to give you kind of an example, kind of a rough version of the example. We need the first term, and there's a second term, third term, fourth term, and then our fifth term is 28, and then there's a sixth term, etc. And then this keeps going all the way at least to the 20th term here, which we have 88. When I want to find out a common difference, and this could have been applied to this previous problem here, but now they're farther out. When I want to find a common difference, I want to state that I'm adding something over and over a certain number of times to get to 88 here. Now, ultimately, I added a total of 60 because that is 88 minus 28. Ultimately, I added a total of 60. Now, the number of terms that have elapsed from there from 5 to 20 was 15 terms total because that is 20 minus 5. If I want to figure out if I added 60 over 15 iterations of that addition, how many times did I add per iteration? You take the 60 and divide it by 15. This is a y2 minus y1 over x2 minus x1. It's a slope thing, and it's not as obvious as far as how this equation's written to make it happen, but that is what's happening. There are 15 common differences being added. Here's more of the algebra version. There are 15 common differences being added starting from 28, and that gets you to 88. From the number 28, I add the common difference 15 times, right? Subtract 28 from both sides, you get 15d equals 60. Divide by 15, you get exactly what you're looking for. Anyway, 60 over 15 is 4. Sorry for the messy, rough stuff. D is 4. Your common difference is 4. Now, we still need the first term of the sequence. Now, there are a couple things that you can do now that you have your common difference. You could just subtract 4 times. But let's say it was also far away. Let's say we had a far away thing here. You could use your explicit rule, and you can use the value of the term that you are given. We could say a sub n. The a sub n doesn't always mean the last term. It could just mean any term imaginable. We could say, well, if a sub 5, and I'm going to substitute 28 there in a second. If a sub 5 is taking the first term and adding your common difference of 4, 5 minus 1 times, and a sub 5 is 28, then we can use, my common difference is 4, I'm sorry. Then we can use this information to find a sub 1. And I know to you it looks like an equation, but there's a story involved here. It says, starting from my first term, I'm going to add 4 times to get to 28, right? And we're asking what that's going to be. And again, I'm going the slower path this time. 5 minus 1 is 4, 4 times 4 is 16. A sub 1 plus 16 is 28, subtract, and you get a sub 1 equals 12. So the value of the first term is 12. Now that is subtracting 4 to get 24, 20, 16, and 12, right? But another way of putting that, of course, is we're subtracting 4 times. We're subtracting 16 minus 16, minus 16. So a lot that can be told there, a lot of different ways you can go about it. I'm trying to give you the bulk in case how big the numbers are, and you can work out recursion if you'd like to, but there's kind of a nice here and there. All right, we're looking at some infinite geometric series stuff. Well, we don't know if it's geometric, but tell whether the series converges or diverges and explain why. Now we have the dot dot dots right here, which states that it's going on forever. So infinite series, it looks to be geometric because in this case we have a dividing by 2, or in that case dividing by 2 and multiplying by 1/2 times 1/2. And if you're uncertain of that, check 5 divided by 10, etc. Your R value is 1/2. That is an explanation in and of itself that this series indeed converges. As long as your R value is between -1 and 1, or it's a fraction less than 1, I like to say, assuming it's a positive. It's a fraction less than 1, you'll have convergence. And as long as you can find the R value, you're good. Now this one right here, we're multiplying by -2 each time. -2, well, it's not more than 1. I mean, it's less than 1, but it's more than -1. It's outside of the -1 to 1 scenario. It's a number more. The absolute value of R is more than 1 in this case because your R is -2. This is divergence right here. This series diverges. Divergence means that if I kept adding this over and over, I'm not going to converge. I'm not going to approach a finite value. It's not going to get closer and closer to a single number. This is 1 minus 2 is -1, plus 4 is 3, minus 8 is -5, plus, well, the next number, plus 16 is 11, minus, it just goes over here, and bigger, and bigger, and bigger, and it doesn't have to do with the sign alternating. If they were all positive, it would still diverge, and a sign alternate, like this one, a sign alternating here as the numbers get smaller would also converge at a value. They're not asking us to tell you what the convergence is for the infinite sum. That's number 16. But on this one here, just, kind of keep that in mind. And in this one, I'm multiplying by -1/2 and times -1/2 as they're shrinking, but the signs alternate. R being -1/2 here does mean that this one converges because once again, it's a fraction less. It's between -1 and +1. Your numbers are shrinking as you go by here. Doesn't matter if it's positive or negative, as long as it's in between there, we indeed converge. So converge, diverge, converge. Now, if it diverges, we don't need to bother finding a sum when they ask you to. So find the sum of the infinite series if it exists. If it doesn't exist, diverges, no sum, move on. If it does exist, we find it. Now, our formula we're going to be using is to find the sum of an infinite series. We take the first term and divide it by 1 minus the common ratio right there. Okay. So for the first sequence right here, we have, or series, excuse me, we have 8 plus 4 plus 2. Once again, common ratio, sorry, you're going to have a lot of 1/2s here, it looks like. Not very clever, not very inventive, even for geometric series. So you have a common ratio of 1/2. You have value the first term, which is 8. So we're going to substitute straight into there. S sub infinity, the infinite series sum, and it converges, so we use this. It's going to be 8 over 1 minus 1/2, which is 8 over 1/2, multiplying by 2, and that's 16. As you add this over and over, forever, it's going to get closer and closer to 16. Yeah, these aren't going to be too different. I wish I had one of like 2/3 and stuff so we could actually play with a few more. All right, so with this one right here, we have 10 minus 5 plus 2.5, etc. Now, I did mention 1/2 on these previous ones here. Why don't we shake it up a little and, when it has a decimal, why don't we give a decimal version of it? I mean, we couldn't tell one way or the other here, but why don't I call it this time -0.5? Will that change anything if it's a -0.5? I almost don't want to do this now because it would make someone use a calculator. Just so you know, that is also -1/2 in case you're tempted to use that, because I kind of am. So it does converge, so we're going to use the formula again where we start from the first term of 10 and we do 1 minus -0.5 right there. Subtracting a negative becomes addition. So that's 10 over 1 plus 0.5, that's 1.5. See, if I ask you what's 10 divided by 1.5, if you ask me what's 10 divided by 1.5, I don't know. But if you ask me what's 10 divided, so I don't want to do that now. If you ask me what's 10 divided by 3/2, well, I could help you out there because that's 10 times 2/3, and that's 20/3. That's an exact answer. And you know what? Actually, I said fraction. Forget it. I'm not using it. Sorry, decimal. Forget it. I'm not using a decimal. I'm using a fraction here. So I don't even know my own plan because that's a repeated decimal. That would be I don't even know. That'd be 6 2/3, 6.3 repeating, 6.6 repeating. No, it's 20/3, 6 2/3. 2 plus 4 plus 8, etc. We are multiplying by 2. Again, not very clever with the numbers here, but multiplying by 2, that's more than 1. This series diverges. There is no sum. It approaches positive infinity. You do not use this formula. You do not. This formula falls under the pretense of the geometric sequence sum. The geometric sequence explicit rule right here. It falls under the pretense that you're using an R value when this is infinity, that you are using an R value that is less than 1. If an R value is more than 1, this is not what we'd arrive at. If it's less than 1, we do arrive at this for that very reason. And I don't know if we get to use this. Sorry, I put S sub n. I meant A. No, I didn't. I'm sorry. For geometric series, I said sequence. For geometric series right here, that it's assuming that you're using an R value that's less than 1. So you do not use this formula for those other cases. You diverges, no sum, leave it. Or sum that goes to positive infinity. All right, and the last 3 problems here. Find the sum of each. We've done a couple ones like this one here from 1 to 25. But this one, this is very clearly, if you know your arithmetic sequence formula, this is clearly an arithmetic sequence. This is your value of your first term. This is your common difference. I don't think we need common difference for it. No, you don't. But there's your first term. So like I don't need to plug in 1 to find out the value of the first term. So your a sub 1 is negative 12. We do need to find the value of the 25th term, however. So that's going to be negative 12 plus 4 times 25 minus 1. So negative 12 plus 96, which is 84. So you have the 25th term being 84. So now we have to find the sum of the first 25 terms in this sequence of the series, of the terms of the sequence. So it's 25 over 2 times negative 12 plus 84, which is 25 over 2 times 72. 72 over 2 is 36. And 25 times 36. If I have 36 quarters, how much money do I have? 4 quarters in $1, $9. That's 900. That's 900. There's my sum. I'm going to trust I did all that right, but there's my sum. All right. 2 more. And, okay. So with this problem right here, what we have to pay very close attention to is this does not say n equals 1. It says n equals 17. Now, another bit about our formula, I keep bringing this up, the S sub n equals blah, 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 blah. What you got to understand is that, when we say a sub 1 in the formula, like this, by the way, this is an arithmetic sequence because of the multiplication aspect. When we say a sub 1, we don't just mean plug in 1. We're saying the value of the first term in your series. I could put an I if you want the initial term, whatever. But I want to just avoid kind of confusion. For the most part, it's the first term. But in this case, it's a little different than that. There are other ways you can work around that. You could find the terms from 1 to this and subtract it from 1 to 86 and all that. But the first term for us is the 17th term. Now, the other part you really have to be careful of is how many terms there are in this thing. And we'll get to that. Let's start with finding the value of the 17th term, the first term in our series. We are going to find the value of the 86th term as well. So this is the first term and the last term in the series. So I'm going to substitute. And this is a fraction. That's another part about this problem that's not most fun. And most people here will be more a fan of 1/5. You can get an exact decimal out of that. I'm gonna not because I'm me. So negative 17/5 minus 5 is minus 25/5. So that's going to be negative 42/5. Now, that is an exact number. That's negative 8.4. So it is an exact number if you want to use it. I'm going to leave it as negative 42/5 for now in case something goes awry. I don't think it should, but, I think I'm trying to kind of teach that lesson. Don't be afraid of fractions. Work them a little bit because sometimes you have to use them, And when you have to use decimals, sometimes you can use a calculator, So this is going to be negative 86/5 and then minus your 25/5 there, which is negative 111/5 like that. So your first term, your last term, 17th and 86th. Now the next question is how many terms are there in the sequence? How many numbers are there between 17 and 86? Conventional wisdom would ask you to subtract 17 from 86, and you'd be very close to your answer, but you wouldn't be on it. 86 minus 17 is 69. Now, 86 minus 17 is 69, but there aren't 69 terms here because if you're counting, if I asked you to count from 17 to 86, in this case, we have to also count 17, right? We don't just go 18, 19, 20, 21, whatever. We start from 17. 17 is also included, but when we do a difference of numbers, we just start counting up 18, 19, 20. We got to start 17, 18, 19, 20. There's an extra term that's needed. One more term that's needed. There's 70 terms total. You got to make sure that the 17th term is included. Like if I ask how many years are between 2018 and 2022, one could argue 4 years, another could argue 5 years. If you talk about the beginning of 2018 to the end of 2022, are you counting 2018? Or are you counting 2020? You know what I mean? We're counting both, the 17 and the 86. So there's your n. There's your a sub 86. There's your a sub 17. All right, so let's find that sum. Now, s sub 70, 70 terms, is 70 over 2 times this negative 42 fifths plus or minus 111 fifths, like that. Okay. So s sub 70 is 35 times negative 153 fifths. Now 35 over 5 is 7. I don't have to deal with that anymore. I still got to do 7 times 153. So 7 times 153. And I'm getting negative 1,071. S sub 70 is negative 1,071. Did y'all get the same thing when you added those together as decimals? Oh, negative 111 fifths should be negative 22.2, I think. So as long as you added those things together, it should be that right there. Was it guaranteed that we were going to be getting an integer with fractions? Not necessarily, but because it was 70 terms, that is an even number of terms. Or, sorry, not an even number. That is a multiple of 5 number of terms there. So I suppose it's within reason that would have happened. So I'm going to trust the answer for what it is, even though I did a lot without the calculator until the final multiplication. All right, and the last problem here, a geometric sequence, but not of the explicit form that we've been used to. We're used to an n minus 1, and that changes things. That changes things because I don't want you to assume that the first term is negative 4, because it's not. The value of the first term is only negative 4 if this is n minus 1. This doesn't have n minus 1 to it. That means it's kind of the 0th term, really. To find the value of the first term, you got to substitute that 1 for n. Negative 4 times negative 3 to the first power. Negative 3, that's positive 12. So your first term is positive 12. Now your 10th term, is huge. Your 10th term, this is going to be a big answer. So negative 3, you make sure that you're using parentheses around that negative 3. Negative 3 to the 10th power is 59049. I'm just going to do this all in the calculator here. Negative 4 times negative 3 to the 10th power. Times negative 4, it's going to be negative 236,196. Let me kind of rewrite that. Hold on. It's negative 236,196. There we go. Huge number there. And we got to find the sum of these first 10 terms right there. Oh, you know what? I don't need the 10th term. I'm sorry. This is a geometric sequence. What's our formula for that? We don't need the 10th term. We're going to be doing something with respect to sum, but for a series, I was thinking arithmetic series here. So in a geometric series, in a finite one, it's s sub n equals a sub 1 times 1 minus r to the n over 1 minus r. What we need is the first term. I needed that. We need the common ratio. Now the common ratio is still negative 3. It's the base of your exponential bit right there. Your common ratio is negative 3. And you need your number of terms, which is indeed 10, because that is from 1 to 10. By the way, to work that thing out, if n was 10 minus 1, the answer is not 9. There are 10 terms from 1 to 10, right? That's why we do that plus 1. That's why we do that plus 1 right there. So I'm kind of just marrying that concept. So these are the 3 things that we needed here. Value of the first term, common ratio, and n. We don't need the 10th term for geometric series, finite geometric series. It's still going to be a big number. Big negative. Well, actually, I don't know. Is it going to be negative or positive? Because this series alternates, right? So it'll be what it is. So the series for the first 10 terms of this geometric series is a sub 1 times 1 minus your common ratio, raised to the 10th power, over 1 minus your common ratio. Oh, excuse me. 1 minus your common ratio. Now, people are used to, listen, you can go to the calculator here. It looks a little bizarre because the fraction bits here, we expect an integer value. Everything in this sum is going to be an integer. You're multiplying by -3 over and over from an integer. So this looks weird, but if everything goes right, it should be an integer answer. So S sub 10 is 12 times. Now, I'm not going to do 1 plus 3 to the 10th. I have to do -3 to the 10th first. And I was kind of making that case before. I was stating that wrap it around parentheses. Now, order of operations, sorry about that. Order of operations says we got to do this to the 10th first. That makes this a positive. So I'm going to be subtracting that positive. 59049. Now, this is minus the negative. 1 minus -3 is 1 plus 3, which is 4. 12 over 4 is 3. I'm going to clean some of this up myself first. I like to do that just to make sure the calculator doesn't make any woes, and so you know that this is an outlet you can choose. So S sub 10 equals 3 times 1 minus this is negative that. So I'm going to do 3 times that number. Negative 59,048. And we get negative 177,144. Yeah, big. I guess not outlandishly huge because they alternate sign. It goes a little positive, then a little more negative, then a little more positive, instead of just staying totally positive or totally negative as you go along. All right, there was a finite geometric series. I'm glad we landed on one of those, even though we didn't do too much on geometric sequence. All right, guys, that ought to do it for this one here. Got it within about 50-ish minutes time. That ought to do it, and that's all I'm really going to be talking about for series and sequences, probably for a while, unless I dive into any word problems. No guarantees on that. This is Mr. Robinson. Thank you so much for watching. Take care. I'll see you in the next one.